So once we've got our turbine installed, now we got to operate it. We got to make sure it's working well, and we need to maintain it. Mick Sagrillo is famous for having mentioned that wind turbines are not toasters. You cannot just plug them in and walk away. It just doesn't work very well. So these are some of the parts of operations and maintenance that we're going to cover here on this discussion, which also covered in chapter 15 of Paul Geip's book, Wind Power. So Paul doesn't list it as commissioning, but he calls it the first rotor turn, I believe. And most of the rest of the world refers to it as commissioning. You've got to make sure everything's right. You need to make sure that it performs the way it's supposed to. Most turbines will have their own user manual, and that user manual may have some checklists that can be used to verify that all the correct things have been done. Once we have it running, we need to be able to monitor it. Is it working well? Does it need maintenance? Are there some adjustments that could be made? Then, of course, if we determine that maintenance is required, that it isn't operating correctly, that maybe there might be something we would want to do, or maybe there's something we want to do on a recurring basis, monthly, semi-monthly, annually, whatever. Occasionally, these things are going to break. They're mechanical. The more mechanical pieces you have, the more likely that they will break, and we will have to repair them or pay to have somebody else repair them. Periodically, there will be upgrades that can be made. That might be upgrades to software or monitoring systems or even hardware. Especially if you get it under warranty, they may find that a batch of blades is prone to cracking, and so they'll replace the blades for free. Or maybe not free. And then lastly, I have decommissioning listed here. I bring this up because in our site assessment section, one of the things that was discussed was that sometimes the permitting process will require the installer to have funds set aside to decommission the machine in the event it's no longer functioning. So here's what the commissioning is all about. And this can be for whether a turbine is installed by an individual or a dealer does this. A checklist is a great idea to have because it helps you to remember things that you wouldn't maybe normally remember on your own. Certain measurements can be made, whether they are a torque measurement or a visual measurement or some sort of metering that could be used. There are different monitoring systems that can be available with the equipment, or we may have to use third-party metering, actually take a multimeter and measure this or measure that. If the turbine is going to be net metered, we want to make sure that the meter that we're using with it, and I'll go to a photo here from Paul's book on our kilowatt hour meter, right? So it's showing here that this one has 6,918 kilowatt hours on it. Oh, excuse me. The reason I bring this up is because not all meters have the capability of turning backwards. Some power companies will require a second meter to be installed, one that is used for revenue and one that is used for consumption. And in that case, we may have two separate meters. Or more preferable would be a meter that could spin both ways. So this is an example of what one of those would look like. It's quite an old one. And then there are other issues that are unique to a standalone machine, meaning something that has a battery backup system. If there are batteries, then there's more equipment to look at than something that was going to be connected to the grid. Monitoring is really important because, I mean, think about it. Especially if you're an off-grid system. If you had an off-grid system, wouldn't you want to know the depth of charge on your battery system? That would be akin to driving a car without a gas gauge. We wouldn't think about doing that. A few of us have, and maybe you've been stuck because you thought, well, I only went so 100 miles. so far, and I'm low to put gas in, but that can sometimes trip you up. So we want to have all sorts of metering that's available. By BOS on the screen, I mean the balance of the system. There might be metering built right into the system, uh, voltage, current, or even power gauges built right into it. We might be able to monitor temperature or RPM, or wind speed or wind direction, or the direction that the turbine is yawed into. So there are many things that we can optionally uh, have installed when we're bringing the turbines in. We can also have some on-site metering. If you've ever been down to the Fort Atkinson campus, you'll know that there is a video monitor mounted on the wall in by the front desk near the lounge. And it is dedicated to data coming from the turbine. And so we can see real time how well the turbine is operating and what speed it's operating at, how much energy it's created, and so forth. They also have some online monitoring, which I'm going to go over to and find it. So here we go. So this is what Northern Power Systems has for the Fort Atkinson campus. And right now it's not functioning correctly. I've got an email into them, and notice it flicked over to the current status while I was hovering over this. And hopefully we will see an example of what it's supposed to look like here any moment now. There we go. And so this is an interactive, not really, this is not interactive. This is purely one way. And so what it's showing is that when the turbine is running, it's going to be stepped up into a transformer, and that transformer then can either supply electricity to the building, or it can supply electricity to the grid if there happens to be no demand. So normally this display actually shows the wind speed in the direction, and it will indicate the number of kilowatt hours that's being generated, and perhaps even the temperature. If you notice the link up here, feel free to use that in the future. Hopefully I'll have this fixed in the near future. There's also a spot here that says links. Okay, and under links we can either link to the college or to the college webcam, or back to Northern Power Systems. Now this was installed in 2009, back when Madison College was known as Madison Area Technical College. So if you click on this link, it's going to take you to a new screen that will be a dead link because it's no longer the correct URL. Here is the corrected URL. And so one of the things that I can see here is that there's the wind turbine. This is the Northern Power Systems machine. This is a live shot. In the background, we can see the Fort Atkinson High School has their 50 kilowatt endurance turbine, which is nice. And we can also see the little Berge XL1, which will be taken down, by the way, as part of a workshop on May 6th, 7th, and 8th. This is the guy that's going away. So we can see here that the turbine is indeed spinning, is indeed generating electricity. So when I look here at the Northern Power Systems under the current status, the fact that it doesn't have any live data means that the link is not functioning correctly. And that's something that we'd want to monitor. And we would want to call the company and say, why isn't this operating correctly? It could be that we're not paying the subscription for it. We don't know. So we have online data collection. We have a camera. There's also utility metering. And I'll give you an example of that. Back here on this website, I have something that was put up by a company called Fat Spaniel that I believe, when I look at this, it looks like it was purchased by ABB. So right now it says that that 50 kilowatt machine is generating 5.3 kilowatts. That's not very much. It's not giving me a whole lot more information. Let's see if we can get some detail. When I click on the detail tab, it tells me that right now it says that it's generating, and under energy, it's showing how many kilowatt hours it's generating, or we could click on the power. And under power, we can see this is a bit more than we had thought, right? It's showing that it's generating 17.5 kilowatts, right? So that seems about right. It'd be an instantaneous. So this is an average between the two. Okay, so it's showing the different nodes and how often it updates. So here we see it updated at 1:15 today, and then it updated at 1 o'clock and 12:45. And okay, so every 15 minutes it's going to record the data. That is something that got collected. What about the voltage? That particular machine has an output of about 282 volts. And if we were to take that voltage and divide it into the power, we would see that the current is what's going to be what's varying. And the current, notice the current is spiking up and down along with the power. The voltage stays constant. Very interesting. The voltage is staying constant. We can then take a look at what the trending has been for a whole week, for an entire month, and notice the voltage stays pretty steady over the month. But what about the power? Over the last month, we're going to see the power's changed drastically. It looks like April 20th was a pretty windy day, but the 21st, not so much. All right, over a year, let's see what we can gather. While we're waiting for that, notice we can scroll back and forth. It looks like November was nice and windy. Okay, typically the summer things die down, right? We can see the spring winds slowing down in April and May, and then June and July. So this is not a good time to install. There's two ways to look at it. This wouldn't be a bad time to install a wind turbine, but once the thing's up and running, you may not have a whole lot of wind to show you that it's working correctly. And then notice here there's this spot that says CSV, comma separated values. Okay, comma separated values. We're going to go back to the simple view and see what it says. It has been updated now to be 17.7 kilowatts, and we can scroll back and forth to see what it was like earlier this morning, and to see, and it will be able to scroll forward to the remainder of the day. We can also take a look at the amount of energy that has been offset. We can see that in its lifetime it's generated almost 350,000 kilowatt hours of energy. Wouldn't it be nice to compare that to the Northern Power Systems machine? And notice here on the overview, the total energy, the environmental offset or equivalent, and the pollutant offsets were also available. But again, this link isn't working. So I apologize for that. Come back and look at these another time. I will do my best to get them running soon. So there we've seen the different kinds of monitoring. As far as maintenance, most manufacturers are going to provide some documentation that tell you how often you should do some work on it. Okay, I'm going to show you the Northern Power one, right? Under Northern Power here, and by the way, I'm going to place a copy of this manual on the web page, right? The Northern, this was just one of several manuals that they gave us. And if we look under the table of contents, we're going to see what's covered. Well, some safety information, some turbine architecture, what the system looks like, its major pieces of equipment, and so forth, how to install it, the major components, operations, and then finally we get down here and we're going to see that indeed there's a maintenance schedule that can be read about, right? The Northwind 100 maintenance schedule and bolt torque table. That gives you an idea of what we're going to need to be working on. All right, so I'm going to click on a bookmark that I put right here, and it shows that these tasks outlined should be done once a year. What should I do? Replace the main shaft bearing grease cartridges, empty the grease catcher, check the yaw gear box oil and fill if necessary, put in, grease the yaw bearing. You know, most of this stuff needs to be done, all of this stuff needs to be done from above. So these are some of the tasks that we will do in the in the Wind Systems Technician 1 class. We will be climbing up to right here, and we'll be tagging it out, going in this door, climbing up here, coming outside, and we'll be doing the maintenance on that turbine. Alternately, we could pay somebody to do it, and that's what the college's point of view has been for quite some time, is that we will just pay for it. We've had the machine since 2009. It was under warranty for 5 years. And so last year, in 2015, was the first year we had to pay for maintenance, and it cost $1,150 plus parts. Okay, it's likely that the college is going to shift some of that maintenance over to our class. So if you take the Wind Systems Technician 1 class in the fall, you will likely be some of the people that will be going aloft and doing this work on the turbine. Other things are common sense, right? So let's say you can hear a noise coming from it, a sound. What's that sound? Maybe I want to stop and go inside and look. Maybe I want to check my monitoring to see if anything has changed. From time to time, we know we're going to want to do some cleaning and painting. And this was outlined fairly well in Paul's book, right? Paul's book showed a guy climbing down, right? Not on this one. These guys here, what they're doing is they're learning how to work on a turbine, probably, and they're doing random bolt checks, right? So periodically you have to go in and check to see whether or not the blades, not only the blades, but also the tower is correctly tightened. Now, normally it's done on a 10% level. You'll just go through and you'll check the torque spec on 10% of the bolts. So you have to count how many there are, figure out which ones you're going to do. And if it turns out that some of those bolts are loose, if more than 10% of the 10% that you check are loose, then that may warrant going through and tightening more bolts, perhaps even all of them. Takes time, but that's why we have maintenance. And this is an example of why we would be doing preventive rather than reactive. I know a fella up in Milladore, Wisconsin, that had his turbine tower tip over, and there was some speculation whether the base bolts could have come loose and tipped over, or if perhaps foul play was suspected and somebody literally loosened the tower when it was not windy, and then it tipped over when the wind picked up. In any case, the tower was damaged, but it was able to be repaired and stood back up, and it's had years of good service ever since, especially since we're doing the preventive maintenance on it. So I mentioned a little bit about service providers. These would be the people that you may want to end up working for. It could require a bunch of travel or perhaps or relocation. And I want to make one more comment about cost of downtime and availability. If this is your turbine in your yard, then there's the cost of downtime is limited to how much of your electric bill you would like to absorb. But if it turns out you have an off-grid system, and if your system isn't running, you might be running some sort of a fossil fuel in your generator, or just going in the dark, then downtime can be a real issue. But if it, for example, is the turbine in Fort Atkinson, and we went back to this screen right here. We went back to this view and went back to the yearly view for the power on the detail here. Let's go to the detailed power view, and let's scroll back on, we can use that. We'll say yearly. And when would be a good time to do that maintenance? How about February 16th? How about in the middle of February? Would that be a good time to do maintenance on a wind turbine? Well, if I'm concerned with losing the electricity that's being generated when it's operating, yeah. But if I'm living in Wisconsin, no, I really don't want to climb up there when it's 10 below zero. Okay, so how about if I do it sometime during the summer doldrums, when the wind stops blowing, sometime around between June, July, somewhere in this time frame. And so they're showing an exact month, right? So if I click on monthly, right, and if I go back to, let's see how far back they're going to let me go. They don't let me go back very far. But if I were to be able to go back to the entire month of July, which is possible here, if I were to download this comma separated values, I could go back an entire year and I could look at what are the traditionally the non-windiest times of the year. That would be a perfect time for me to do that maintenance, because I'm not generating any energy then anyhow. All right, and that's especially important for a machine that's part of a wind farm that perhaps the power company is counting on that wind and the energy that you're creating to offset their fossil fuel generation. So we need to look at that. As far as doing repairs, well, again, we could have a service provider come and do this. Well, sometimes then you're at the mercy of that service provider. If that service provider um, is unable to come when it's broke, then what? Then it sits. How long does it sit for? A month? 2 months? It's measurable and can be calculated, the amount of of energy and revenue that you would then be losing out on. But there's also warranty issues. While your turbine is under warranty, that service work might have to be required by a certified service provider, which I guess only makes sense. What happens when it falls outside of the warranty window? Who's going to do that work? And again, when I talk about availability, I'm referring to how long is it going to be down, and thus reducing its capacity to be online and making energy. I want to back up and talk a little more here about repairs. Some of the repairs that need to be done could include, common off-the-shelf electrical devices, or it might include proprietary equipment that has to come from the manufacturer. But then what happens if you find you have a machine and the manufacturer is no longer in service? Then what do you do? For example, um, uh, the in, the endurance machine that I showed you at the high school in Fort Atkinson, that's a 50 kilowatt machine. They also manufacture a 5 kilowatt machine. But sometime in the last 2 years, they had decided to take that particular machine off the market. And so that means they're not going to support it very much anymore. They're not going to be making new parts and so forth. So what happens when your blades break? What do? You try and find some used ones. Maybe somebody has a machine that burned out, but the blades are still okay. That could be what you do. Some of the repairs we may have to make might be to the blades. We had a blade issue that was caused several years ago in Stevens Point. We had some shear force winds that occurred. Normally, when the wind blows, it gusts and it drops, and it gusts and it drops. And yeah, that might gust up to 50 miles an hour or 60 miles an hour, but then it drops back to 40. So things that bend in the wind, like trees and poles and towers, they're able to bounce back during the times when the gust stops. Well, so these sustained forced winds, this would be a continual force of wind at 50, 60, 70, 80 miles an hour of sustained wind were found. And what ended up happening, it wasn't that the blades broke, it's that debris was thrown through the air and it struck the spinning rotor. So that rotor was really flying. The machine was protecting itself, but some large piece of debris flew through the air and it damaged 2 out of the 3 spinning blades before it passed on through. So that's an example of some of the repairs that need to be made. And sometimes this could be one of the issues where if you have a machine that's so obsolete and you cannot get parts for it, this might be a case where you're going to be repairing or just decommissioning the machine. So also a possibility. As far as upgrades go, the dealer may suggest some. They may find out that they sent out a batch of blades, like I mentioned in the beginning, and that those blades are prone to cracking. And because of that, they have redesigned the blades, and they're sending out a set of blades, and it could be at the company cost, or it could be that if it's out of warranty, that the owner has the option of paying for that themselves or living without it. So. Most manufacturers would like to stay in business, and they are going to try and make it as um, reduce the inconvenience to the owner as much as possible. The owner may want to make some changes themselves. For example, that turbine I told you about up in Stevens Point that had the blades damaged. The only thing we could do was trim the third blade and reseal it. So we ended up taking 9 inches off of all 3 blades. 2 of the blades, it happened because of the storm damage. The third blade, we had to do that in order for it to be matched in length and therefore balanced and therefore performing correctly. So that little bit took away a significant amount of energy. If you remember, the amount of wind is determined by the area of the rotor. And so if we took this was a 17-foot diameter machine, and we lowered it down to be a 15-foot diameter machine, just a little over 15 feet. So that had an impact on it. Other performance upgrades might include working on the balance of the system. Perhaps they've come up with a more efficient inverter, and that inverter upgrade would then have a much better power curve and be able to extract more energy from the wind. Decommissioning, like I mentioned earlier, it can sometimes be required in the installation permit. For example, if it's a $10 million system and you've got however many turbines are involved with it, the permit that was issued by the authority having jurisdiction may have also included that the developer or the owner of the turbines have an escrow amount of money set in the bank so that in the event a machine is broken, rather than just have it sit there in a state of disrepair, abandoned, that the authority having jurisdiction could take that money from the bank and pay somebody to remove it. But we want to do that anyhow. If a turbine is broken, we want to take it down or we want to get it fixed because it's an eyesore and it's a black eye on the industry if we have dead turbines out there. It's just like your neighbor with the broken down truck in his front yard. It makes the whole neighborhood look bad. But for us, it makes the industry look bad. And quite often, what we hope that will happen is that that old turbine that's beyond its 20-year lifespan will be replaced with something newer, whether that's a brand new machine or perhaps it would be a machine that was refurbished and came out of a wind farm. So that is pretty much what we have to discuss here. There are a couple of shots in the book that I forgot to mention. I'll just quick cruise over there. And so these are the guys torquing the bolts. I got another shot here. This is this turbine, when you first look at it, seems pretty small until you realize, wow, look at the size of that car. This is just on a great big hill, okay? So rather than doing a lot of digging with the with the foundation, they instead put a big dirt berm up around the outside of it. So it's a reinforced concrete tower. Make sure you read Paul's book on this. Again, I wanted to show you, here's a picture of the guy doing the cleaning on this. So why would we want to clean a blade? Well, because if it's clean, it's more aerodynamic, and the machine, now what he's cleaning is the tower itself and not the blades, I think. Really hard to tell. He could be scaling down a blade, not sure. But notice he's using a pressure washer. What do you think that pressure washer is going to do? We know it's going to make it wet, right? And so you can see the types of shoes he has on here. Hopefully will keep him from slipping too much. And interesting job. And then on the next page, we have a shot of a guy using a boom lift. This would probably be the easiest way to do maintenance on a machine, but it has to be able to lift high enough. And so we're not sure what machine we're looking at here, if it's a Vestas or what. So anyhow, that is the end of our discussion of Paul Geip's book on wind power.